Hello everyone, welcome to 60 Seconds to Code, where I show you how to code in 60 seconds or less, as usual. Well, not as usual, unlike usual. I'm not going to be doing a 60-second video today. I'm going to be doing a much longer video because the 60-second videos don't seem to be as popular, but the longer form videos seem to be gaining a little bit more traction on the channel. So today I'm going to be showing you how to create a code converter API with Amazon Bedrock, Amazon API Gateway, AWS Lambda, and we're going to be using Terraform for our infrastructure as code, and we're going to deploy everything, and we're going to be managing our code using GitHub, and we're going to be deploying everything using GitHub Actions. So let's get into it. Okay, on the agenda today, we're going to quickly go over some definitions and technologies. Then I'll give you a very short architecture, and then we'll go into the meat and potatoes, which is going to be the demo. So that's the agenda for today. Okay, what is Amazon Bedrock? Amazon Bedrock, I believe, became generally available sometime in 2023. It's a fully managed service that makes high-performance foundational models available from leading AI startups and including ones that Amazon developed, other artificial intelligence models, large language models, the ones that were developed by Meta and other things like that. Those are available in basically a serverless manner, which means that if you want to use a large language model solution or an LLM generative AI solution, or any basically generative AI solution, because the Amazon Bedrock doesn't necessarily include all just LLMs, but other foundational models, including embedding models, as well as image generation models. So Amazon Bedrock you can think of as the serverless service that makes available these large language models for you to be able to use and call within your applications, and basically gives you a framework / API to call with which you can make calls to the Amazon Bedrock to the foundational models as necessary. And from my previous videos, you probably already know Terraform is the open source infrastructure as code management solution that was developed by HashiCorp, and that's the tool that I'm going to be using for my infrastructure as code today. Basically, it's a declarative configuration language that allows you to declare what infrastructure you want to deploy, and we'll go over the infrastructure we're going to be deploying as part of our solution in just a second. But basically, you just write the infrastructure, and it's Terraform's job to deploy the infrastructure, or basically bring up the infrastructure as you have declared it in the files. AWS Lambda is a serverless computing service that allows you, the developer, to create snippets of code and run snippets of code in pretty much any language or any runtime language of your choice without having to manage or worry about provisioning servers. You just declare, this is the code I want to run, and the AWS will then be responsible for provisioning the underlying servers, etc. Basically, it's a serverless compute or serverless function service by AWS. GitHub Actions, it's a CI/CD platform that allows you to automate your build and test and deployment pipelines that you can use to deploy your code and your infrastructure that you've written on GitHub. And API Gateway is Amazon API Gateway is the AWS service for creating, publishing, managing, and maintaining REST and HTTP and WebSocket APIs at any scale. So after these quick definitions, this is the architecture that we're going to be working with today. GitHub and GitHub Actions is what we're going to be using for our Git repository and for our CI/CD, which means that our workflow, the deployment workflow that we run as part of Terraform's infrastructure as code, is going to be run using GitHub Actions. Terraform is what we're going to be using to declare our declarative infrastructure, and the infrastructure, after the infrastructure declaration, the GitHub Actions will be responsible for running all Terraform commands to actually deploy the infrastructure to our Amazon account, and basically then what we're going to be deploying is a regional API gateway. That API gateway is going to be calling a backing Lambda function. And this Lambda function is going to be making a call to the Bedrock foundation model. So using this API gateway, I'll just put in a sample to deploy the API gateway. And basically via this sample, we will be able to make a call to the Lambda function. The Lambda function will then create a Bedrock runtime client. That runtime client will make a call to Amazon Bedrock foundation model. In our case, it'll be Claude, and that foundation model will then respond to our request. In our case, it will be a request to convert some code from one language to another. So let's get into the demo. Before we get into the demo, what we're going to be doing today is not in the free tier. What this means is you definitely need to look at the pricing for Bedrock, and once you do, you need to determine that whatever you do deploy to your account, you just want to make sure that you're okay with paying that price. However, at least for the foundation models that I've used so far, Bedrock is actually fairly cheap. You only pay for the API calls that you make, and I'm not going to be making very many API calls. I'm going to be very limited in the number of API calls I'm going to be making. But if you create an API, or if you create a public facing API and you leave the API running, then someone can discover that endpoint and just run up your price by making a call to your foundation model over and over again, which is a bad idea. So don't leave the API running, and basically I will show you how to deploy and destroy the infrastructure. And by the way, you will find the code link, the link to the Git repository, in the description below. Some of the prep work that you need to do is that you need to request access to the Bedrock LLM, and you need to create a user with an access key pair that you need to use, that you will be using in the GitHub Actions, and I'll show you how to do all that in just a second. And then I'm going to be going over the setup of the GitHub Actions and how I set up the GitHub Actions to actually deploy my infrastructure to my AWS account. I'm going to be quickly going over the Lambda function code that is going to be the backing Lambda code to the API gateway endpoint, and then I'm going to be going over the Terraform configuration and the Terraform resources. So let's get into it. Okay, I am in my AWS account, and the first thing you need to do is if you don't have Amazon Bedrock and you're recently visited, you can just click the search bar and look for BEDROCK, and you will find Amazon Bedrock. And within Amazon Bedrock, the first thing you need to do is you're going to be presented with the Amazon Bedrock splash screen. Click on Get Started, and on the left hand side you need to go down to the Model Access section, which is this section right here, this link right here, and click on Model Access. And then you need to request, at least in my case, the ones that I'm going to be using is Claude from Anthropic. That's the foundation model that I'm going to be using. But for you, depending on the foundation model that you need to use, if you want to use my code, you will need access to Claude. If you don't want to use my code, you want to use some other large language model for text or anything like that, you need to request access to that foundation model. And the way that you do that is on the top right corner, this little orange button right here. You click Manage Model Access, and then you need to select the checkbox that you want to get access to. So for example, let's say go here, let's use Titan G1 Lite, use that one, and click Save Changes. When you do, I'm not going to do that, I don't need access, but when you do that, you will be requesting access to large language model, and then you need to wait until this access granted checkbox next to the large language model or the foundation model is set to access granted. If it says available to request, then you will not be able to follow along in the rest of the in the rest of the demo today. So that's your first step. Your next step is for you to create an IAM user, but in my case, I'm using my primary user's identity and access management key, which is this one right here. But you need a ID access key and access key ID pair, secret access key and access key ID pair that you can use. And basically, I'm going to be showing you how to set up the GitHub Actions secrets, and how to add those access key and ID pairs into GitHub Actions secrets, and then you can use those to actually run your pipeline within GitHub Actions. What I'm not going to be using today is I'm not going to be using OpenID Connect. With OpenID Connect, it's a lot more secure. Basically, this is just a demo video, but with OpenID Connect, what you can do is you can configure OpenID Connect with GitHub Actions, and you can request temporary key pairs from the Simple Token service from Amazon. And basically that's a much more secure way of requesting credentials from AWS than actually creating a user, then going to the user and creating a security credentials, and then embedding those security credentials within GitHub secrets and putting that as part of your pipeline. That's a little less secure. If you want, you can look up OpenID Connect with AWS and GitHub Actions, then you'll find all the documentation on how to do that. But for today, I'm not going to do that. But for your user, basically, I'm going to be deploying a bunch of resources. But for the user that you need to create, this user needs to be able to deploy the resources that we're trying to create, which is going to be a bunch of IAM resources, some policies, the Lambda function, API gateway methods, etc. The user that I'm using currently is an admin user, so it's going to have all those privileges intact. So it's up to you if you want to use an admin user, or you want to create a new user and only limit the privilege of that user to the resource you want to create. That's a lot better, security wise. But you need to create a user. Obviously, I already have a user. If you don't have a user, you need to create a user. Don't use your root account. Create a separate user. Go to that user and click on the Security Credentials tab, and under Access Keys, click. I already created 2 access keys, so it's not allowing me to create an access key. Personal key. So you just need to create access key, and I'm not going to be able to run through that demo with you right now because I'm using both these keys. Don't worry, if you try to use my key, I don't have to disable either of these. If you were to try to use either of my keys, even if you were to discover the secret, I'll disable both of these in just a second. So you can try it, but you're not going to be able to access my account, trust me. So I'm not going to be graying this out. But you need an access key and a secret access key ID pair that you're going to be entering as part of your GitHub Actions. Those are the 2 things that you need as part of your prep work. Okay. We did request access to the Bedrock. We went over that. We went over how to create a user with access key and ID pair to be used in GitHub Actions. Now let's go ahead and go over to our code and take a look at the code. So you will find the URL to my code converter API, Git repo below in the video description. So this is my code right here. But first, let's go ahead and take a look at the GitHub Actions workflow. And I have created 2 GitHub Action workflow files. One is called the Terraform init plan apply, one is called the Terraform plan and destroy. And these 2 are the ones that I use to apply my infrastructure as code, and this is the one that I use to destroy my infrastructure as code, and I'll go over these in turn. So okay, let's take a look at the Terraform init plan and apply.yaml file. This is the github.github/workflow folder. So for anybody who's not familiar, if you want to add GitHub workflow actions, you need to add this folder, and in this particular folder structure, add a .github folder and then /workflows, and within that /workflows, you need to define your YAML files that are going to contain your GitHub Actions specifications. So I have defined 2 here. One is for the apply and one is for the destroy. So let's take a look at both of them in turn. So I'm going to dispatch on workflow dispatch. Basically what this is doing is telling me that this workflow is going to run only when I dispatch the workflow, meaning Only when I manually click the run workflow button while this workflow be deployed, you can run it, or you can run the workflow as part of a merge to main if you want, or basically when a pull request is pulled into main, or a push is done to main, whatever you want. But in my case, I've made it so that it's only when I manually click the run workflow button is when this workflow is going to be run. And the branch that this workflow applies to is only the main branch. Again, you can specify the branches from it if you like. The name of the workflow I've defined. You can define a name of the workflow as well. Feel free to use mine if you like. Now, the rest of these this basically I only have one job, and this entire job is going to have multiple steps, and those steps are going to perform the Terraform, basically the Terraform workflow. We're going to be running it on the Ubuntu latest. I would say it would probably be a little bit faster if you were to run it on your own. What's that called? Docker container. I'm not running it on a Docker container. I'm running it on the the GitHub runner, the Ubuntu latest GitHub runner. But the reason I say that's probably faster to do it in a runner of your own, well, in your case a Docker file or a Docker container, it would be that so that you don't have to do this setup of the Terraform, the second step, every single time. You can create a you can create a Docker file that already contains the Terraform CLI in it, so that you don't have to run this setup step each and every time. But in my case, I'm not doing it. I'm just doing it a little bit slower. First, what I do is I check out my code. Obviously, it's the simple checkout action everybody's familiar with. But then I do need to set up Terraform, because without Terraform being set up, I can't run any of the Terraform workflow commands, such as Terraform init, plan, apply, none of those, because the Ubuntu latest, the default runner, doesn't come with Terraform installed on it. So I need to set up Terraform before I need to run any of the commands. After I set up Terraform, and then I need to initialize the Terraform, and I need to run the Terraform init command. The backend config is where the first time I'm going to use my access key ID pair, which is going to be, if you remember just a second ago, we created the access key ID and the secret access key pair. This is the command you need to run Terraform init, and with the backend config, the access key that you need to provide this is basically what you need to use as the command. And what you need to provide it is the access key and the secret key pair. And you need to provide it just like that I've shown you within your workflow command. And in order to set this up, what you need to do is you need to go to GitHub Actions and click Settings, click under, it was Actions, yep, and actually it was under Security, yeah, Secrets and Variables, Security, Secrets and Variables. Under Security, Secrets and Variables, click on the Actions button, and there you will find the secrets that you can set up for your repository. I have set up multiple secrets. The secrets that I am interested in is the three secrets that I'm going to be using in my workflow. I have named TFVAR access key, TFVAR account ID, and the TFVAR AWS secret key. And the access key ID and the secret access key you need to set up in the access key and the secret key pair respectively in your repository secrets. And then you need to, because without them being there, obviously this command won't run. Now, for the purposes of setting up the backend, what I have done is I have, within my AWS account, I have created an S3 bucket. And the S3 bucket, obviously the secret access key ID pair that written in your secrets, it needs access to this S3 bucket, because this S3 bucket is where I'm going to be storing my state file. And this state file key is the folder that I'm going to be storing it in. But you're obviously change the name of the bucket, create a bucket within your AWS account, and within that bucket name it whatever bucket you like, and within that bucket specify a key, meaning the folder where you're going to be storing your state file. Set up the region, and this is where your Terraform state file is going to be stored. Now, if you want to set up the backend such that if you need state locking, for me, because I'm the only one running this, I don't need state locking, so I'm just using the simple S3 state management solution. But if you want, you can read the documentation on how to set up the backend, AWS backend with S3 and with S3 and DynamoDB to include state locking. But for me, I didn't use DynamoDB for state locking. I'm just using the classic S3 backend. So that's what is needed in order to, let me go ahead. I don't know what I did there, but I'm not going to save it, whatever I did there. Okay, here we go. So that's what you need as far as your TF-var, AWS access key, and ID pair. So that is what you need in order to make sure that your Terraform init command runs as expected. The next commands that I'm going to go over are going to be the Lambda function. Now the Lambda function code, I need to package the content of the Lambda function, this folder, as well as all the dependencies that this Lambda function needs, into a zip file before I upload it to Lambda. The reason I had to do this, and the reason this pip install our requirements txt file, this command is there, is because the classic or the current version of the Bodo 3 library, Python Bodo 3 library, actually does not contain the Bedrock runtime client. And because it does not contain the Bedrock runtime client, all my calls to creating the Bedrock Bodo 3 client Bedrock runtime, all these calls were failing because the Bodo 3 client, Bodo 3 library version that is available with the current version of Lambda does not have the Bodo 3 client for Bedrock. So what I had to do was explicitly define a Bodo 3 version that is higher to one that actually does contain the Bedrock runtime client. And you can take a look at the rest of the dependencies if you want. But basically what this does is it installs all these dependencies as well as the lambda function.py and the file that this is the lambda function.py and the lambda handler. This is the function name that is going to be the entry point for my function. And this is the code that is going to run. And without doing this package step, which is this step right here, if I don't package this lambda with a newer version of the Bodo 3 library, running or basically this call to this Bodo 3 client for Bedrock runtime is going to fail. So that's why this was necessary. So what I'm doing literally is packaging up, changing directory into my API Lambda folder, going into and installing all the requirements within the requirements.txt file that you just saw a second ago, packaging up all that into a zip file so that my Terraform code can use it. And we're gonna go look into the Terraform code in just a second. Then I'm gonna run the Terraform validate command just to make sure that everything works as expected, meaning there isn't any configuration problems within my Terraform code, or any declarative problems or any statement problems within my Terraform code. After that, I'm going to run a Terraform plan. This Terraform plan is actually going to output a plan file, which is this file right here. I'm calling it TF plan. And again, this Terraform plan is going to require the AWS access key and secret key pair, which is what I'm using as the secrets which we entered a second ago in GitHub Actions. So what you're going to do is you're going to go into GitHub Actions, find from your IAM access key pair the one that you created, go to GitHub Actions, go to settings, go to secrets and variables, go to actions, and add 2 new repository secrets. Actually 3. One is going to be your AWS account ID, copy the account ID for the account under which you're working, and you're going to need to specify the access key and the secret access key as environment variables as well, because the access key and the secret access key are the ones that we're using within our Terraform init, Terraform plan, Terraform apply commands. So this plan is going to be using the AWS access key as the secrets from the GitHub Actions. It's going to be outputting a Terraform plan file. So let's go ahead and quickly take a look at the main.tf file, and you can also take a look at how I have configured and set up the the AWS provider and how I'm using the AWS access key and secret access key. You can read documentation on this if you like. I'm not gonna go into a lot more details on this. I've already harped on this a lot. So now this is just, I was doing some troubleshooting step. You don't have to do this step if you don't want to. I was just taking a look at what the, what exactly the location of my zip file and my artifact files were. And I'm going to be uploading this artifact file, our plan file as an artifact. Technically speaking, because I'm not, running it in multiple, jobs. If I'm running it at a single job, I don't absolutely have to do this. This is not necessary, but it's probably a good idea for you to, output the plan artifact as part of your GitHub workflow. This step I have copied it out because I didn't need it anymore, but I was just playing with something on how to basically require a manual approval. And you can take a look at this manual approval and how it is set up. But basically, if you uncomment this, what this will do is, within your repository, it will create an issue, and that issue will will say that you have to reply to this issue with either approve or approved, etc., before this workflow will proceed. And if you reply to that as approved, then the workflow will proceed. In this case, I have commented it out. But in order for you to to be able to do this, you have to read the documentation for this TRST stringer manual approval GitHub action. And for this manual approval GitHub action, you will need a secret that will allow you to create the issue, or that will allow your workflow to create this issue. So you will need to create a GitHub Actions token. That token will need access to your repository with the ability to create issues. But again, you can read the documentation for this one if you want. If you uncomment this and read that documentation, I'll do that. But for me, I'm just going to leave it commented out. Finally, it's going to echo approve, and then it will do a Terraform apply. So let's go ahead and go to the GitHub library and click on Actions and run our init, validate, plan, and apply. Again, I'm going to click on Actions button, and I'm going to click on the Terraform CLI workflow, and I'm going to run the init, validate, plan, and apply workflow. I'm just going to click Run Workflow and watch it run. And I believe, I've already deployed all the infrastructure. So this should finish without having created any new infrastructure, because the infrastructure already exists. So let's go ahead and watch the Terraform. And yeah, this is where it's doing the requirements installation of the Lambda file. Now it's running the Terraform validate, and it's now running the Terraform apply. And yep, everything worked as expected, and the Terraform application and creation, everything worked as intended. So let's go ahead and take a look at the Terraform apply. And it were created. Let's go ahead and Terraform plan. Bedrock Lambda. Okay, because the source code has changed, that's why it updated my Lambda code. So there you go. There's your, there's the application, and my infrastructure has just come on board. Let's go ahead and take a look at our Lambda function code. For our Lambda function, import JSON and Boto3. Again, if you do a classic import of the Boto3 library from the Lambda runtime environment, the problem is it won't contain this Bedrock runtime client service, and these calls will start failing. So you do need this requirements txt and the package Lambda package in the zip file format that I've shown you within the GitHub action. This is my Lambda handler, and this is the one that I'm going to be using within my Lambda code. And this event object is what's going to be the event. You obviously can comment out the print event, statement. I was just using it to see what it looks like. And I'm going to be using prompt, which is where I'm going to be getting the body of the message that is entered in the event as the prompt for my as a prompt variable. And then I'm going to be using the prompt variable within this JSON.dumps, and I need to basically create this body as part of the Bedrock client runtime invocation, because without this format, and basically it really depends on the type of the model you're trying to invoke. So let's go ahead and go to Bedrock and take a look at Claude V2, I think, or is it V2.1? I'm not sure which one I'm using here, but let's go ahead and take a look at what that looks like and why I need to build it like this. Okay, so let's go to the Bedrock, and yeah. So if you go to Amazon Bedrock, click on Get Started, and find base models under Foundation Models. You can look up each model that you're looking for. In my case, the model that I'm going to be calling, I tested a few models, and I think the best one for code conversion, meaning which allows me to convert the code the best, is probably Cloud V2 by Anthropic, which is this one right here. And if you click on Cloud V2 by Anthropic, it will give you the details, the cloud model, this Cloud 2.1, 1.3 cloud, and so forth and so on. And this is where the API request that you need to model within your JSON dumps is specified. So if you take a look, basically the model ID content type accepts body and Anthropic version. These are, I think these are pretty much uniform across different API requests. But for different types of models, you need to construct the API request as follows. So if you let's take a look back at my code. I have specified, the prompt, the max tokens, the temperature, etc. I would say 0.5 is probably the right temperature. Don't set the temperature too high. Don't set the temperature too low. But you can play with the temperature setting a little bit if you want to see what what setting seems to be best. 0.5 seems to be right for me. And notice that the prompt that I'm using is the one that I provided, or that I'm getting from the event body. So that's what I'm putting within the prompt, and I am constructing my body as follows, just like the API request suggests on the model page. And then I am making a invocation by running bedrock runtime.invoke model with the body and the model ID and accept and content type, so forth and so on. You can also find that within the documentation for the invoke model, bedrock runtime invoke model function, and it'll tell you exactly what you need. And then you can get, after we invoke the model and we get a response body, we are going to load the body of the response into response body, and we're going to find the answer in the body.getCompletions, and then we're going to return the answer as an answer to an under body and in the answer. So that's what we're going to return, and this is the format the API gateway expects. So depending on the application you're using, whether it's whatever you're calling the Lambda function with, the return might be slightly different based on your use case. So that is my Lambda function and my Lambda code, and that is how I'm making a call to my API. So now let's go ahead and take a look at the Terraform configuration resources. The main.tf, I went over this already. You need to specify the AWS provider, and in order, basically I'm using the S3 backend. You can use a different backend if you want to. I didn't have a chance to test with many backends. The first one that I used, or the only one that I used, was S3. You can try different backends if you want to, but this one seems to be, at least working for me very well. The provider and the secret access key and secret key variables, you need to set them up exactly with how you see on your screen, and you can obviously clone my code to see how that's done. And finally, we're going to go over the Terraform configuration and its resources. We already went over the the main.tfl. Let's take a look at the resources. Let's start with let's start from the bottom. Let's start with first the AWS Lambda function. This Lambda function is what's going to be the the Lambda function that is going to be running and calling the Bedrock runtime API function calls. The file name in this case is going to be the lambda.zip. This is where the code of this Lambda function is going to be. And if you remember, within the plan and apply, we're actually zipping up this code within this step right here in package lambda.zip code in the zip code. So this is our resource right here, and that's the file name of the function code. The name of the function is going to be Bedrock Lambda. You can, call it whatever you like, Bedrock API Lambda, something like that. And the role that we're going to attach to it is this one right here, which is Bedrock role .arn. We'll come to this in just a second. That's going to be what we're going to be reviewing next. And this lambda function .lambda handler is exactly the name of this lambda function .py and lambda handler, which is this one right here. It has to be named the file name .function name. So it's lambda function .py .lambda handler, or lambda function .lambda handler is what is expected within this. That this is the basically this is the entry point and the name of the entry point function for your lambda code. The file base64 SHA. This is the SHA for the zip file. If the zip file changes, it will redeploy the the zip file, and for most of the time this is going to change, at least because you repackage the lambda code each and every time the SHA changes, because each time the zip occurs, even if the content of the files are exactly identical, the timestamps changes. So that's why, if you saw just a second ago when I did the redeploy, even though the function code didn't change, the source code hash did change, which is why it had to redeploy the lambda function. So you can tweak it a little bit if you want to, probably archive your code or store your code, or do something to do to make sure that it doesn't redeploy every time. But I don't think that, at least for my purpose, it wasn't necessary. This is an important configuration, the runtime timeout. The invocation model for Claude v2 actually was taking a very long time. I first tried it with 5 seconds, for 15 seconds, and then finally I settled on 30 seconds. The lambda runs until it gets a final successful response from the invoke model API, but that sometimes takes up to 20-25 seconds in order for that to complete. So that's why I had to set the timeout this so high. This Bedrock role is what is going to be giving the permissions necessary for this lambda to make a call to the invoke model, and invoke model with responses, API calls for your Bedrock runtime. So this is what you would do. And finally, you are going to allow the lambda function, which is this lambda function right here, to be able to assume this role. So that's what you need right here. You need an inline policy so that this role is able to make calls to the Bedrock runtime API, and then you need to allow the lambda service to be able to assume this role. Next, you need to give the invoke lambda permission, so that the lambda function that you're creating, which is this lambda function right here, can be invoked by the API gateway. So you need to specify the invocation action that this lambda should be invocable by the API gateway, and the source that you need to specify is the source ARN that you need to build is specified right here. I've done some inline string interpolation using different variables, the my region, the account ID, and different variables. You can take a look at how I've done this, but this is the method and the path for the API that you need to specify for the source ARN, so that the API gateway can actually invoke this lambda. Next, we have the integration method. This specifies or lets the API gateway know that for the post method that we're using, which is the code converter post method right here, this needs to pass this the request over to an AWS proxy. And the AWS proxy that we're going to be using is this lambda function right here. So this is the lambda function, which is the Bedrock lambda that we specified below. And basically what this is telling the API gateway, that whenever you go to that particular method on that particular resource, which is a post resource, I want you to pass that request over to the lambda function. So that's what this is doing right here. This is my post method, nothing special there. This is the resource path part. You can create obviously additional path resources. So mine is / code converter, and within that code converter path, I have the post method. You can choose to use it or not use it within the base of your API gateway. That's totally up to you. And this is my REST API gateway right here. Obviously, I need to create the API. I need to create the API gateway resource. I need to create the method. I need to create the method integration in order for me to be able to call that post method. And finally, I need a stage upon which I can deploy my API gateway. This is the code deployment stage. I've called the stage dev. You can call the stage whatever you want. And then finally, I've done an API gateway deployment. It's kind of a funky thing. There's a bunch of stuff I had to do to make sure that the deployment, the code converter deployment, goes as expected. But basically, what I'm doing here, this is probably the most important line, the trigger of a redeployment, which checks that if the API gateway dot code converter dot body, which is this one right here. Let's take a look at AWS API gateway code converter, which is this one right here. Whenever I change the body of this request, then the SHA is going to change, and that will trigger a redeployment. What this will do, excuse me. What this will do is if I were to change this, the description a little bit, it will trigger a deployment. And another thing is that I've done is the stage description. I'm using the the file. Actually, I don't even remember what the stage description was. The file resource. I don't recall what I did here. But these dependencies are actually required. The reason they're required is because there is a race condition that occurs if a code converter, if this deployment occurs before you create this post method the first time, or if this code converter and Lambda integration doesn't exist, then this deployment is going to fail. So I had to add these two dependencies explicitly. Otherwise, this this wasn't working for me. So there you have it. And that's it. We have gone through everything. So let's go ahead and take a look at the API gateway. So let's go to API gateway, and let's find my API gateway. The name of the API gateway should be something to the effect of code converter. There's my code converter, and there is, let's take a look at my resources, and there's the path resources. That the path is / code converter, and within it there's a post method. There's my post method right here. Notice that there's a Lambda integration, and if you take a look at the integration request, it's actually passing the post integration request over to the Lambda function. The Lambda function is actually the one that does the fulfillment of this post request. And let's take a look at when this was. Let's take a look at the stages. I only have one stage, and the last time that it was deployed was today, this morning at when I did the last deployment. So that is how you deploy the API gateway. So let's go ahead and go to generate SDK. Where is my resources post method? Yeah, actually not import API. I forgot where it was, but if I remember correctly, it's in here somewhere where I do need to get the API code converter. Is it stage actions? Delete stage export. Yeah, there it is. So under API code converter, under stages, find your stage. In this case, the dev stage. Click export, and click the Open API 3 specification in JSON format, and say export with the Postman extensions, and say export API. And this will export your API into a Postman collection. So let me go ahead and fire a Postman. Alright, Postman is starting up. Minimize this. Find Postman. Where's Postman? Come on, Postman. There goes Postman. I believe I already had a collection, so I'm gonna have to delete the old collection because I think, yeah, I'm only allowed like 3 API collections. So let's go ahead and delete code converter here. Dismiss the updates. Go to environments. Where's my collection? Code converter. There should be a code converter collection. There it is. I'm going to delete that one as well. Nope. Hang on. Let me make sure that I get my API body. Yeah, there it is. Let me get that body. All right. So I'm going to copy that body, and now I'm going to go ahead and delete this collection. I'm going to use that body in my next post request. So let's go ahead and copy that onto my clipboard. Yeah, and then delete the old collection. Delete, and then go File, Import, and find the collection that I just downloaded. Download Stream Converter. Imports. And there you go. And there is my code converter. And there is my post method right there. And in here, I'm going to use body and raw in JSON format. And I'm going to paste the content that I had. Now, I will put the body or the exact format in the you know what? That's a good reminder. Let me go ahead and put that in the Git repo right here while I'm on, before I forget. So let's go to new. Where did it create at? Let's find a new file. Let's call it postmanbody.json, and let's paste that in here. And git add git commit added postman body, and then you can use this as your sample. And notice what I did here. If you want to know what I did here was I first actually went to AWS Bedrock, and under, where did it go? BDROCK. I go to Amazon Bedrock, and I actually asked the large language model, in this case the cloud model, by going to the cloud, to the Claude playground, not the cloud, C-L-A-U-D-E, Claude playground, and asking it to generate me some Python code for actually reading a file and posting the content of the file to the terminal. And then basically what I did was I took the content of that, and I am asking it within this body request, the content of that. Obviously everything is escaped, so you're going to need to unescape it in order to figure out what my body looks like. But what it's asking is, I want you to convert the following Python code into Node.js, right? So what this is going to do is, let me go ahead and save this request. What this is going to do is it'll use this body, convert the following Python code, and it will pass it first to the API gateway post method. That post method will invoke this Lambda function. The Lambda function will receive that event, and the event will contain the body, and then the prompt will be, I want you to convert the following Python code into Node.js code. And then it'll make an invocation to the Cloud 2.1 model. The Cloud 2.1 model will convert that code from Python to Node.js, and then it will get a response body, and then we will return that the response's answer back to the client. So let's go ahead and take a look. That's what's happening here. And if you want to take a look at my code, you can copy my code body into any JSON escape tool and unescape it and see what my code looks like. But let's go ahead and send this over to the API endpoint. and let's wait while. Now remember, the Lambda function takes a long time to actually make the call, but we should be getting a response back from the Cloud Anthropic model, giving us an output of the, yes, there it is. So here's the answer. Here's how you can convert the Python code to Node.js, and you can go ahead and copy the response onto your clipboard and put it in any JSON escape tool and escape it and figure out what the content looks like. So that's it for today. I hope you enjoyed the video. This has been a long one, but what we did today, if I can find my PowerPoint presentation again, what we did today was we looked over at our GitHub Actions setup, we looked at the Lambda code, we looked at the Terraform configuration and everything, and with this, basically now I have given you the boilerplate, the template, to make any calls to the Bedrock runtime model using your Lambda code in Python, however you like. Right? This time I'm asking it to convert the Python code into Node.js code, so it's actually converting. But remember, this question can be anything. I can ask anything of it, and the response will come back. Right? So technically, this is a code converter API, but it can be anything. Any thing that the Claude 2.1 model supports, I can ask it as part of the body, and I can get the response back. So there you have it. But as I promised, and this is I would recommend you do as well, definitely destroy your, you need to destroy your resources. The reason you need to destroy your resources is because this API, if somebody discovers it, they can keep making a call to your API endpoint and run up your AWS build quite significantly, which is not what you want at all. So I'm going to go ahead and go to Actions, if I can find. For some reason, it's going very, very slowly. I don't know why. There it is. I'm going to go ahead and run my destroy workflow. It is very, very slow for some reason. Come on. Well, I don't need to make it part of the video, but I will definitely run my destroy workflow. You need to do the same. Because you just want to make sure that you don't leave the API out there for somebody to find and run up your Amazon bill. So thank you very much for watching. I appreciate it. Until next time, I will talk to you guys later.